Today we're going to continue talking about domain and range. But first, let's go ahead and review the terms. Domain, that's your input values. And those are the x values. Range, those are your output values. So those are the y values. Okay, so we're looking for domain and range of these three graphs. When we're talking about domain, we're going horizontal, the x values. We're looking for the lowest x value to the highest x value. And in this case, the lowest x value right here is -2, but that circle says it doesn't actually touch -2. It gets infinitely close, but it never actually touches it. So for the domain, we could write x is greater than -2. And then it goes all the way up to 2, and there's not a circle there, so it actually reaches 2. So we could say that x is less than or equal to 2. In our previous lesson, this is how we would write it, but I'm going to actually show you a different way today. I'm going to show you a less formal way of writing your domain. So the less formal way is to write it as -2, 2. And on the left side, it does not actually touch -2, it approaches it. So we're going to open up parentheses there. So we're going to open it with parentheses. It approaches -2, and it reaches +2, so we're going to close it with a bracket. So this means it approaches, this means it actually reaches. For the range, we're looking for the lowest to the highest y value. Along the way, there is that opening right there at y equals 0. However, right there and right there, y equals 0 actually does exist. So there's no gap in the range. It touches all the y values from -3 up to 3. And it includes both ends. The low end, it actually includes the -3. On the high end, it includes the +3. So it's going to be brackets on both ends. From -3 to +3 inclusive on both ends. And we're going to continue writing domain and range in this way throughout the rest of these. Sometimes we'll use this new way, sometimes we'll use our older way, just depending on what's more convenient for the domain or range of the particular function. So for the next example, the domain x values goes from here to here, but there is a hole in the graph right there. So there's two different intervals, from here to here, and then from here to here. So on the low end, it reaches or it includes 1. And on the high end of that interval, it gets infinitely close to 4, but it's not going to reach it. So we're going to say 4, but it's exclusive. So it reaches 1 on the left, and it approaches 4 on the right. And then there's a new interval, and it goes from 4 to 5, but it doesn't touch 4. It approaches 4, and then it reaches 5. So the domain is from 1 to 4, and from 4 to 5, but it does not include 4. The range is from here up to here, from 1 to 6, and it's got that hole in the graph at y equals 3. However, right along here, there's an infinite number of points where y equals 3. So the range is from 1 to 6, and it is inclusive on both ends. And our last one goes from 1 to 6, but there is a hole in the graph right at 6. So the domain is from 1 to 6. It is inclusive at the 1, but it is exclusive at the 6. It reaches the 1, it gets infinitely close to, or it approaches the 6. And then the range, the y values, here's our lowest, here's our highest. It goes from 2 up to 7, but it does not touch the 2. So that y value of 2 is exclusive. The y value of 7, it touches that. So it is inclusive at 7. So now we're going to find domain and range given an equation. So in our previous lesson, we had 2 hints. Hint A was that a denominator cannot equal 0. Hint B was whatever you find under a radical cannot be negative. Not in the real number system. For example 3 here, that doesn't exist. There's no denominator with a variable in it. There's no radical with a variable in it. So the domain is all reals. So for the range, we're going to turn to the calculator. So we're going to go to y equals, clear out whatever's in there, and we're going to do y equals x squared plus 2. And we'll graph that. So that is not a standard window, so what I'm going to do is hit zoom and option 6 for a standard zoom, and that looks a lot better. So the graph is a parabola, and the lowest value, the minimum, is 2. And it's going to go up forever on the left and on the right. So the range is going to be all real numbers that are greater than or equal to 2. So I could put y is greater than or equal to 2. If I continue using this format, it would look like this. 2 on the low end, infinity on the high end. So it goes from 2 to infinity. But it can never reach infinity. When something is infinitely close to infinity, it's got infinity farther to go. So it'll never actually reach infinity. So we would say it reaches 2 on the low end and it approaches infinity on the high end. So that's my domain and range for example 3. For example 4, I have a denominator with a variable in it. And a denominator cannot equal 0. So that means x cannot equal 2. So my domain, I would say the easier way to write this one is all real numbers except x cannot equal 2. Then I'm going to go to the graph, clear that out. And my calculator is not going to do this as a fraction, so I'm going to hit divided by, and then I have to put that denominator in parentheses so that it puts that x minus 2 all in the denominator for me. And then graph. Okay, so this seems to confirm that x cannot be 2 because it approaches 2 from the left side and it approaches 2 from the right side, but it never crosses over x equals 2. But it also approaches from the bottom, y equals 0, and it also approaches y equals 0 from the top, but it will never touch y equals 0. So the range is all real numbers. It's going up forever, it's going down forever, but it is not touching y equals 0. So y does not equal 0. Okay, so here I've got a denominator again with a variable in it. X squared plus 2 cannot equal 0. So x squared cannot equal negative 2. And when I take a square root to get rid of that squared there, I get x cannot equal plus or minus the square root of negative 2. Okay, but we're only dealing in the real number system. And this right here is non-real. So there's no real number that's excluded from my domain. So the domain is all real numbers. And we'll graph it to find the range. So 1 divided by, and then I'll open up my parentheses, x squared plus 2. And close the parentheses and graph. Okay, so that's kind of hard to see. So I'm going to do zoom and then option 4, decimal. And I get a much better picture of it. I can see that on the left and on the right, it's approaching 0. It's not actually going to touch 0, but it will approach it. So the range on the low end, it is approaching 0. On the high end, I need to find out what that maximum is. What's that highest point? So I'm going to do second and calc. So I'm going to calculate. And it's a top of a graph, so I want option 4, a maximum. I'm going to go a little to the left of that maximum and hit enter. I'm going to go a little to the right of that maximum and hit enter. And I'm going to hit enter one more time. And it tells me that the y maximum is 0.5, so it goes up as high as 1/2. And that is inclusive. And the last one on this page, I've got a denominator again, x times x plus 5 cannot equal 0. So this is already in a factored form for me. X cannot be 0, or else that would make that factor a 0. And to make that factor a 0, x would be a -5, so x cannot be -5. So the domain is all real numbers, except x cannot be 0 or -5. Now when I graph this one, I have to put the numerator in parentheses because it has 2 terms. And then the denominator in parentheses. And it's got another set of parentheses to open. And now I've got 2 sets of parentheses open, so I need to close both. So this confirms that x cannot be 0. I can't really see x equals -5, so I'm going to zoom 6 to get a standard window. And it still really doesn't show me that gap where x equals 5. But if I trace -5, it's going to show me no output. So at -5, there is no output because the x value of -5 does not exist on this graph. It also appears to approach 0 from below and from above, so the y value can never be 0. So the range is all real numbers except y cannot equal 0. Now we're going to look at a restricted domain. When the domain is restricted, we're only looking at a portion of the graph. And limiting the x values will very often affect the range. So in example 5, this right here is my domain. All x's from 3 to 5. So I'm only looking at that part of the graph. So it's this right here. The lowest y value on that interval of the graph is 3. And the highest y value on that interval is 6. Then I'm looking at a domain of x's from 0 to 3. So just this interval of the graph. The lowest y value is 0. The highest y value is 4. And here I'm looking at a domain of -2 to 0. So this interval of the graph. The lowest y value is here and here, they're both 0. The highest y value on that interval is 3. Okay, so we're going to look at some graphs on our calculator. We'll look at the first one on the calculator at least. So go to y equals, clear it out, x squared plus 2, and graph. Okay, so that's that parabola that we looked at on the first page. So it looks like that. But we only want to look at it from x values of 0 to 4. So from here to here. I'm only concerned with that portion of this graph. So when x is 0, it's pretty clear the y value is 2. So the lowest y value on that interval is 2. The highest y value, I don't really know just by looking, but if I go here and trace, the highest y value is going to be where x equals 4. I get an output of 18. Now, what if I don't have a graphing calculator? This one would actually probably be a little bit easier without a graphing calculator, but this is a good time to learn some of those foundational graphing skills that we're going to use later on. But now, if I don't have a graphing calculator for this, if I input a 0 for x, 0 squared plus 2 is 2. And if I input a 4 for x, 4 squared plus 2 is 18. That gives me my range. In example 4, if I input a 3, 1 over 3 minus 2 is 1 over 1. And 1 over 5 minus 2 is 1 over 3. But we have to be careful here. Even though that's the high end of my domain, its output is the low end of the range. I got 1 over 3. That's the low end. And in this last one, if I input a 1, 1 squared plus 2 is 3, I get 1 over 3. And if I input a 10, 10 squared plus 2 is 102, so I get 1 over 102. That is the smaller fraction. So that's my low end.